Hello and welcome. In the next 5 minutes, we'll look at the architecture of a 64-bit real-time operating system platform that uses today's best commercial off-the-shelf technologies to deliver hard, real-time performance for large, complex systems. Let's take a look at the key components of this RTOS platform. First, we see the Windows operating system. Then we see the 64-bit multi-core multiprocessors and the RTX64 software, including deterministic scheduler and symmetric multiprocessing capabilities. The Microsoft Visual Studio provides the integrated development environment. Now let's take a look at this RTOS platform architecture in detail. First, notice the 64-bit hardware platform. You will notice that some processors are assigned to RTX for real-time, others are assigned to Windows for non-real-time activities. The processor affinity is the ability to allocate and then statically assign a processor to a particular process or to a thread. In this case, we can see that RTX can range from one processor in a dual processor system all the way up to 63 processors. Windows can have multiple processors, but at least one must be assigned. Next, let's look at the operating system layout. You will notice the Windows operating system and the RTX64. It's important to note that the RTX64 HAL extension does not modify, alter, or change the Windows HAL in any fashion. Next, look at the RTSS, or real-time subsystem. The real-time subsystem is where you will spend most of your time and where all the hard real-time performance is achieved. An interesting detail to note is that this little extension into the Windows says that any Windows application that is running may be preempted by any ready-to-run RTX process. That means that RTX can never be preempted or blocked by a Windows process. Next, you can see the TCP IP stack. This will be used if you have any need for a deterministic network application. We turn our focus to four processing types of applications. The first is a Windows process, a pure Windows process that you would find in almost any implementation. The second is an RTX64 process. This is where you spend your design time achieving your real-time performance. There are two others that are hybrids. The Windows process that is linked into the real-time subsystem and a Windows driver that's linked into the real-time subsystem through their individual APIs. It's important to note that the RTX64 processors are loaded by its loader and scheduled by a deterministic RTX scheduler. The Windows are handled by its own Windows loader and Windows scheduler. Also, please note that some Windows processors are loaded into user mode space and others are loaded into kernel mode space, where all of the RTX processors are always in 64-bit kernel mode space. Finally, let's take a look at the real-time subsystem in detail. To touch on a few, the RTSS scheduler is both priority-based and preemptive, essentially meaning that the highest priority thread will always run. No Windows thread can ever preempt an RTX thread, and the highest RTX priority thread will always run on its allocated cores. Threads are scheduled across the allocated RTX cores based on each processor. Windows assigned to its processors and RTX assigned to theirs. Floating point operations are supported with no additional setup during compile and linking of your program. Structured exception handling within the RTX64 application behaves similar to Windows. The subsystem is responsible for local deterministic memory allocation. Also, the subsystem is used for attaching interrupts of RTX64 control devices within the real-time application using traditional ISRs and ISTs. Shutdown handling, or the ability for a real-time application to safely control its behavior during a Windows blue screen or even a normal Windows shutdown. And finally, communication between the various Windows processors and RTX processors, or even between two RTX processors. It's handled by familiar inter-process communication objects such as events, semaphores, or mutexes. Thank you for watching this video. This is the first in a series of RTX64 videos. This will be posted to our website and in addition to our YouTube channel.